Testing, 1, 2, 3. All right, ladies and gentlemen, welcome back for Lecture 2. We're going to start in just a few minutes. In the meantime, though, can you hear me? How do I sound? Great. And maybe a more important question, does anyone recognize this song? What game series do you think this current song is from? Any ideas? Interesting. No suggestions. What does this sound like it's from? In the past, students could look at the browser tab where it would be showing a YouTube video being played, and that would give it away. However, this semester we are introducing a bold new multi-monitor approach to lecturing. Super Mario 64, kind of? This song was Windy Valley from Sonic Adventure. Okay, let's go on to the next. We got about 1 minute to enjoy the next song. Someone's got it in chat. Listen to my story. Right? This is such an incredible piece, full of emotion, brings a tear to my eye, and it is the Final Fantasy X opening to Xenarkand. Very, very emotional track, and I just finished Final Fantasy X before the summer ended. And so it's a very, very meaningful piece. And I've always found... Wait. Absolutely incredible. I've always found, and this may not surprise you, that much of the enjoyment I get out of music comes from the memories and emotions that I can attach to the piece. So while I might not have cared about the song much before I played this game, after playing the game, suddenly it means so much more. And so I know very little about music, but its power cannot be denied. And so let's go ahead and get started, ladies and gentlemen. Thank you for joining us. I'm still crying. It seems there's a lot of memories for this music in the chat even. I know this game is part of many people's childhood. So, anyway, ladies and gentlemen, thank you for joining us for the second lecture of EECS 494. Hopefully the web captioner, we've got it going again, but hopefully it sticks with us this time as we go. So today, I want to get into a few things. I want to explore a bunch of different systems in Unity. I want to cover the logistics of the course. In case you haven't read the syllabus yet, we'll go over it very briefly. And if we have time at the end, I want to talk about the philosophy of code reviews as far as composition goes. So not inheritance, which you might be used to, but composition, which is really core to how we build games in Unity and to how games are made in general. So anyway, let's go ahead and get to it. So a few announcements to start us off. Office hours are coming up, and these all happen in the Discord server. So you'll go there when it's time. Thursday at 9 a.m. EST. If you have any troubles with the Tutorial 1, Tutorial 2, if you want any advice, or if you just want to hang around and chat about video games, Ishwar will be in the Discord voice channel Thursday 9 a.m. EST. Okay. On Friday at 9 a.m. Ishwar will also be doing a totally optional, but potentially very useful and impactful discussion section on the topic of kind of getting the Unity environment set up and optimized, the Unity workflow, so that you can be extremely efficient even this early on. Ishwar will be going over some tips and tricks this Friday at 9 a.m. And then right after that, Amber will have her office hours at 10 a.m. So if you want some help at 10 on Friday on your Tutorial 1, Tutorial 2, then that's definitely something you should go to. Okay? It feels a little bit odd putting all these so close together. We're gonna see how the schedule works. And if you have any suggestions, please let us know. While I don't always catch all of your Twitch comments, I do catch them when I review the lecture later that night, okay? So please let us know what you think about the office hour schedules, and we might do a little remix later in the semester, okay? All right, so some motivation to begin the week. I do like this image. It says, be like a duck. Above the surface, you're composed. Everything is calm and organized. You have it all together. Beneath the surface, you gotta go crazy, all right? You gotta put that effort in, that investment in, get a little bit innovative, be a little bit nuts, right? Paddle like hell. This image, it kind of speaks to the idea of, right, you may know someone in your life, you may be that person, right? You're doing a ton of stuff, right? And you've got a busy schedule, you all do. Right? You've got a ton of stuff you're doing, a lot of classes, you're extremely busy, and there are very difficult things asked of you, right? Now, you want to be able to control all that. You want to get your discipline down, you want to get habits developed for organization so that none of this overwhelms you, right? Over time, you want to get better and better at handling these responsibilities that are just going to keep coming. Right, you're going to have tons of responsibilities because you are UMich students and you do such a great job and you work so hard. You're very ambitious, okay? So just keep this in mind, right? Be like the duck. Keep working hard and taking on newer and bigger assignments and problems to solve, but always keep working on how do I organize all of these things, right? Is there a way that I can manage my calendar? Can I set notifications so that I never miss anything? Can I develop habits so that I never turn in an assignment that doesn't get double checked, right? So that you never lose easy points. So work on your discipline and your organizational habits at the same time that you're working on your actual assignments, okay? You work hard, also work hard on being organized to make this all manageable, okay? It's a hard job. You can do it. I believe in you. Terry Kavanaugh didn't just release VVV's source code. This is a very, very popular indie game that you may have played. But this just speaks to the fact that there are a lot of games out there that are very impactful and that have sold many copies and made a lot of people happy. And a lot of these games, actually, if you want to see how they're engineered and programmed, you can. This is one of those games. Many indie devs will release their source code. And I have to say, I don't know. What you'll find is that a lot of very successful games maybe don't have obvious architectural patterns to them. And maybe they are not super sophisticated in how they are engineered. However, something to keep in mind is that engineering isn't everything, and there is such a thing as over-engineering, right? So you don't always, particularly if you're making a small game and your deadline is very tight, you don't always want to involve every design pattern under the sun, right? You don't always want to build out flexibility into your systems if that flexibility isn't going to be necessary. So it's not so simple. The topic of engineering and when it comes to game development is not so simple as we need everything to be super well maintained. We need everything to be super scalable. You need to think about deadlines. You need to think very pragmatically as well. The balancing act of, how much scalability should I build into these systems versus how much do I actually need that when I'm looking at the deadlines and the resource constraints that I actually have. Okay, it's kind of a philosophical discussion, one that you will be doing. We'll talk about this a little bit later. In the meantime, it's so cool that Terry released this source code, and of course, congratulations to him for having the impact that this game did. So let's go ahead and keep going. Graduate students, please submit this form. If you are not yet in the class, if you are still on the wait list, please send me an email, okay? We would like to get you off of that if we can. And I think we probably can. But of course, this course is not designed for graduate students, so we have to have some consideration. We have to consider some things. So please fill out this form and submit it to the undergrad advising office and send me an email if you're not yet officially in the course, okay? We plan to offer overrides as soon as we can. Wednesday, maybe next Wednesday. So Monday is Labor Day. So we will be not having any lecture. However, your assignments will still be due, okay? We will not be releasing any assignments. If we look at our schedule here, we will not be releasing any schedules on Monday, any assignments on Monday, but there will be 3 of them due on Monday, okay? So please keep that in mind. The assignments that are due Monday are Tutorial 1, Tutorial 2, and your P3, your P1 partners form submission. A few things to keep in mind, a few tips for you. Whenever you submit something, always download the thing from Canvas that you just submitted. Okay? You need to verify when you submit things in general, whether that be to clients when you're working at your job, or of course during this course. Unfortunately, every single semester we have several teams that submit an assignment only to realize, oh my gosh, I submitted tutorial 2 for the tutorial 1 assignment. And oh no, I submitted tutorial 2 for the tutorial 2 assignment as well. And then the 24-hour deadline, late period passes, and then we can't help you. Right? You didn't submit your tutorial 1, so all those points, they're gone. That's not a good way to start. So please be very careful. Always download something that your team submits and verify you submitted what you think you did. You might be surprised sometimes. There's a 20% penalty, late penalty, if you turn something in less than 24 hours late, but still late at all, okay? There's a 100% penalty. We're just not going to grade it or accept it if you turn it in any later than that. Canvas provides the official timestamp for these considerations. Please do not cut it close. Adopt the habit of submitting a safety submission. What this means is maybe the night before a deadline, even if you're not finished, right? Even if you don't have everything in, even if you got a buggy submission, submit it. You can submit as many times as you want, submit that thing, so that if a disaster happens, we can just grade the thing you submitted. You won't get all your points, but that's way better than a 0, okay? So please consider doing that, particularly as the assignments kind of build in value as the course moves on. We'll talk about that in just a little bit. Assignments released, this released Monday. Please be sure to fill out this form. Again, I will post this agenda to the schedule after lecture, so you can get to this form very easily. The Project 1 Classic Game assignment, where you re-implement Legend of Zelda or Metroid for the NES, starts on Wednesday, next Wednesday, okay? To kind of whet your appetite a little bit for this assignment, I want to show you a spectacular result that we had a few semesters ago. So you might have seen The Legend of Zelda for the NES, and you might have played it, but you've never seen it like this, okay? So Nigel Bale and Jennifer Daly did a fantastic job where for the final part of their assignment, where they implement a new mechanic in a new dungeon, they implemented a motorbike into The Legend of Zelda. And this isn't just for looks, it's a mechanic because you can use this motorbike to jump over gaps. You can use it to take down small enemies really easily. You can use it to outrun obstacles. And there's an interesting speed mechanic to the bike. So there's a slow speed, and if you can keep moving without stopping, you'll go to speed level 2, and then speed level 3. And your speed level determines how far you can jump. In other words, the introduction of the motorbike mechanic to The Legend of Zelda has introduced new navigational puzzles into the mix in a way that's very natural. When you enter a room, your question is, okay, where do I have space to build up speed so that I can jump this next bigger gap, right? So it introduces an incredibly novel and fresh new navigational puzzle to the series. It is just a spectacular P1 gold deliverable. So well done, team. I hope this has whetted your appetite, everyone. You can do essentially whatever you want as far as a custom mechanic with a few constraints we'll talk about later, okay? Anyway, look forward to it. You are currently working on Tutorial 1 and Tutorial 2. Now, Tutorial 1 is all about roll a ball, okay? With some additional mechanics added to it. Jumping and fall resetting. So the game resets when you fall off. I want to show you something that is not required, but is very interesting from a design perspective. So I want to show you the importance of shadows when it comes to platforming. And you can see this in some of the games that have already released on the Discord. I encourage you all to play them. They're very fun, the ones I've seen thus far, and they do an excellent job. But maybe they don't do this. So let's take a look. So I've got a game of Rollerball here. And we'll see if it loads. Sometimes Firefox doesn't want to load the... Oh, here we are. So we got this Rollerball experience here. And we're rolling around a little bit. Now, I'm going to show you what it looks like to try and jump across. We're going to try and jump across these things. However, I'm going to turn off shadows, okay? And I want you to look at this screen and say, does anything look a little bit off or weird to you? Does your brain ache a little bit? Where am... Oh. Yeah, I hoped I wouldn't die there. Okay, let's try this again. Does your brain feel a little bit sore as you watch this and try and figure out where I'm going to fall? Where do I land? Right? It's a little bit hard to tell where we're going to... Oh my gosh. I'm going to count that as a win. So the problem is your brain is seeing a 2D image, a 2D representation of a 3D space, right? Unfortunately, the game has to take a 3D environment and map it to a 2D one, right? Because that's the image you see on your screen. Now, your brain, what it does is it sees this image and it tries to figure out where this ball is in 3D space, but it's hard. It's hard, your depth perception fails a little bit, because in this instance, we don't have a shadow, right? Something that often tips us off to where we are in the 3D space is gone, okay? So I want to show you this when shadows are turned on. And in particular, the shadow works in a very particular way, right? What does the shadow do, chat? Where is it angled? Okay? The shadow is angled down, as in there's a light above us that's casting straight down. The result is that the shadow actually helps us understand where our ball is on the z-axis, right? Depth into the screen. And so suddenly platforming is a lot more tractable and easy for your brain to understand. I want to show you what this looks like in a AAA space, what AAA game designers do when it comes to shadows. Now, maybe you've seen this game before. I really hope it runs okay, because it did not run very well in my testing. But I had Unity open, so maybe that was why. Okay, we're gonna play some Crash Bandicoot very briefly. Okay, very briefly, because we don't have a ton of time. So, has anyone played Crash Bandicoot? While this loads up, looks a little bit framey. I hope we can do this. Yep, Crash Bandicoot, a fantastic series. It was the first video game I ever played for the Sony PlayStation. Oh, it's very
Activision
laggy.
presents a smashing blast from the past.
Unfortunately, it's very laggy. It looks like, I'm not sure why it's this way, but I believe it is. So you know what? We're gonna watch a YouTube video instead. How about that? How about that? Okay, let's get out of here. We're gonna watch a YouTube video of Crash Bandicoot, and I want you to pay very particular Crash Insane Trilogy. Okay, I want you to pay very close attention to how the shadows work in this game, because there's something very unexpected going on. If you look very closely, something weird is happening, something a little bit unnatural even. Right, chat, can you figure it out? I wonder. Let's find out. Okay, watch the shadows, chat, particularly when Crash runs down a hill. So chat, watch Crash Bandicoot's shadow as he runs down a hill, and tell me what you notice about how shadows work in this game. Bingo. Chat, you got it. Right away. Well done. In this game, if you can believe it, Crash has two shadows. Right? Look at that. Look at that. Look at that. If you look closely at Crash, there's one shadow that appears to be just this kind of generic, shaded circle, right? So look right there at Crash's feet. It's very obvious running down a slope. There's the shaded circle that's underneath Crash, and it's always right underneath Crash. And then there is another shadow that's actually ahead of him a bit, running down a slope, and this is a very realistic shadow, right? That clearly takes the form of his 3D mesh as it animates in the running pose. And so this is very surprising result. It's as if the world has two suns in it. And so the question I have for you, chat, is why would the designers do this? They did this very explicitly, and it was a very good idea of them to do this. Why would they do this? I want to show you one more clip of Crash Bandicoot that might illuminate this and give you a hint as to why this was done. Okay? So let's get out of here, actually. And there we are. Okay. This is the famous, very difficult Bridge to Nowhere level, where you're far above the clouds, and there's a lot of very difficult and precise platforming to do. I want you to watch how the shadow works in this stage. No, that's cheating. That is very cheating. No, we need a different video. That is very cheating. Let me see if I can find a video where the cheating doesn't happen. Yes, okay, we gotta okay. Chat, are you seeing this? Are you seeing this, chat? Watch this, watch this. Did you see that? Okay, let me ask you a question. Have you ever seen a shadow be cast on thin air before? Okay, shadows don't usually do that, and maybe you can reconcile this with the idea that there's fog and stuff, and you're casting shadow onto this fog, okay, and that's why you can see it. In reality, the designers needed to have this shadow in there because, particularly on extremely precise and difficult levels such as this, where platforming is in a very deep knowledge of the z-axis and depth needs to be there, the shadow is absolutely critical. Without that shadow right there, this stage would have been much more frustrating than it already is for players. So it's very, very interesting. The game designers are willing to forego reality and realism if it helps the game, if it helps gameplay. And so it's something that you should consider. Okay? And also, if you are still working on your rollerball, please consider taking the directional lighting, which is a game object in your hierarchy, and just kind of rotating it, rotate it down a little bit. You can put in a second one if you like, but help your players out with that z-axis and get some shadow going straight down, okay? You do not need to redo the lighting if you already submitted. This is not going to affect the rubric at all, but it's something to consider. And this is just one instance where the game designers were really paying attention and helped their players out a lot, even at the cost of a little bit of realism, which isn't a huge deal in a cartoony game like this. But it's very interesting that they said, you know what, we want both. So we're going to have two shadows, a gameplay shadow and a graphical shadow, okay? Anyway, something to consider, a cool little case study. Chat, does anyone have any questions? I'm going to give you 30 seconds to ask a question, chat, and then we're going to move on. I feel like I ignore the chat, and I don't want to do that. So go ahead and ask. So there's a question, isn't realism in games only important when it enhances the experience anyways? So I think that really depends on what the developers and what the players are going for and what they want. When it comes to enhancing the experience, that can mean different things to different people. One player might really, or one demographic of players might really want realism from their games. That just trumps everything. While another set of players might expect a certain series to really go for the gameplay elements and really make sure that's working, prioritizing that before gameplay, before presentation. So I think it really depends on what the designers are aiming for. Was it in Naughty Dog's original release of Crash 1? I'm not sure. You can watch a YouTube video to find that out. I beat Crash 1 a while ago. I don't remember if they had it or not. I think they might have had it, because I don't remember it being a huge issue. There's this shadow that's one for one. Okay. There's a game as well. Okay, excellent. So let's go ahead and move on. I want to talk about course logistics. Okay? So course logistics, the famous SpongeBob. Who's familiar with this clip right here? I love this clip from the SpongeBob TV show. Let's go ahead and watch a little clip here.
What's his name? What's his name? I got nothing on a name. Come on, baby, what's the name? We threw out his name!
Right, so this is a pretty well-known clip where SpongeBob is the logistics in his head aren't working too well, to the point where they have accidentally thrown out his name, and that's not good. Let's stay a little bit more organized than this, okay? We can do it. So why wasn't this stuff covered in last lecture? That's a good question, chat. Usually syllabus day happens on the first day of lecture. Why would anyone decide to make it the second day of lecture? Ask yourself this. There is a very poignant reason why we did this. Anyway, lectures, right? So lectures are Monday, Wednesday, 11:30 a.m. EST. And you can find them this semester on twitch.tv/ayarger. Standard lectures, right? There are different types of lectures generally that we'll do. So the standard lectures that we'll do often cover topics like history, some theory, game design theory, discussions, and stories, right? So relating industry stories to you, we'll be doing that a bit. However, there's another half of many lectures that is much more technical. It doesn't focus so much on game design, but the engineering, right? This is a College of Engineering course. It just makes sense. We'll be focusing on implementations, demonstrations of technologies and systems. We'll be practicing. We'll be doing some case studies on how to implement certain systems. For instance, coming up, we'll be showing off how you can design and implement quickly a universal toast system, a messaging system that allows you to, at any moment in your game, send a message to the player that will appear in a really satisfying way and then go away after a few seconds, and how to queue them up and how to make sure it's going to be bug-free and stuff like that, and easy to use. We'll be talking about some low-level stuff and technology, of course, in general. So we will have lectures that are, we probably won't have any lectures dedicated to playtesting this semester. We will go over that topic and how to do it well. But playtesting will be made an assignment that we'll be doing later on from week to week. And on occasion, we will have guest lectures where we'll have an industry alumni, usually, Wolverine, that is having an impact in game development and simulation and other stuff, come in and give a Q&A. And it's very visceral because you get fantastic stories straight from the people who are making them happen. So, in fact, we just had a fantastic Q&A with John Hayase, who is the former vice president of Atari, the head of Visceral Games at Electronic Arts, EA Redwood Shores. They were right above me when I was there, actually, the floor above Maxis. And he was also the head of Sony Online Entertainment when they were creating EverQuest. So please go ahead and look that up on the IGDA Ann Arbor's Twitch channel if you want to see that great interview. We'll have more during the semester, so please look forward to it. And there's another type of lecture that I won't tell you about. Unfortunately, I'm not sure if we can make it work. Okay, I'll just tell you what they were. They were field trips. I'm sorry. I don't know how we're going to do field trips in person this semester. I don't think it's going to happen. Maybe we can come up with some digital field trips, though. That could be pretty neat. So I apologize, everyone. We'll find some other interesting stuff to fill that gap. So a quick reminder on the schedule. These first 2 weeks are going to be, this first week actually is dedicated to the tutorials, kind of getting you up and running quickly. We will then focus on the classic game project. You'll be re-implementing Zelda or Metroid. This first few weeks is just focusing on engineering mostly, right? How to use Unity, how to get up quickly and into that iterative prototyping mode. Then we will focus more on game design. You'll be making some prototype games and just thinking about, okay, now that we know how to build something, how do we build something that is going to be fun, right? And so that's a very hard problem. And so we'll be going over theories on how to do that. So the final, 6 or 7 or 8 weeks will be dedicated to your showcase game where you will mix engineering and game design and art and music and all of that to create a game that is going to please a lot of people, be added to your portfolio, and if you want a job in the industry, hopefully land you an internship, okay, down the line. Portfolios are super important in this industry. So anyway, let's talk about grading and some policies you should be aware of. So in this course, there are around 900 points that you can get, okay? I think there's a little bit more. We've had a little bit of point inflation as extra credit assignments have been introduced and stuff like that. But anyway, and some additional assignments have been introduced, allowing more points. But 1 point is worth, about 0.1% of your total grade. Okay, so points are, they're not super impactful, but they're not something that you should sneeze at either. Okay, you should snag every one that you can. So tutorial 1 and tutorial 2 comprise around 10% of your overall grade in the course. These are a lot of points. It's been said these are a lot of points for such short assignments so early. Part of the reason that these are so valuable is to help you out, right? To help your grade out. So please do not be very careful when you submit these assignments. Don't get penalized. Read the entire spec, do everything it says, and make sure those get in on time. Okay, get yourself a really good start with all those points. Okay. P1 and P2 are both around 17% of your final grade in this course, around 150 points. And your final project is about 400 points, about 44% of your final grade, okay? One thing that's very interesting about these projects is that within one of these projects, within any one of them, there are actually a lot of sub-assignments. So for instance, in P1, there isn't just one single P1 assignment. There's the P1 milestone, which is a 5-day assignment where you have to implement a certain subset of the Metroid or Zelda features. And then right after that, there's the P1 Alpha assignment where you have to implement the rest of the features. And then after that, there's P1 Gold where you have to finish all those features, get rid of all the bugs, and add a custom dungeon and mechanic. And what you'll notice is that as you progress through a project, the sub-assignments get more and more and more valuable, okay? This is to say, this course is designed so that you can mess up early and not be penalized too hard. Here's what I mean. Let's say you're getting into P1 and, you're just having a rough time, right? It's not going well. You're confused about Unity, right? And you're struggling. Well, don't lose hope, because the first few assignments of P1 are actually not that valuable. I think P1 milestone is like 10 points, maybe 15. However, they get more valuable as you go on, and the final deliverable of each project is worth the most points. In other words, it doesn't necessarily matter as much that you're getting it right away. What matters is that you eventually get to the point where you're doing the assignments really well and knocking it out, okay? In other words, if you feel like you're falling behind, that's not the time to panic or get a ton of anxiety. That's the time to go to office hours and contact us so we can help you out, give you some tips, help you with your problems, okay? Before the going gets valuable. So make sure you keep that in mind if you're struggling early on in a project, so that we can get you back on track before the points start to really be on the line. The stakes rise as you go along. And then there's a 100-point participation assignment, 11%. And normally this would be related to attendance. So you need to attend the lecture on time, you need to be there for check-ins, otherwise you lose points. However, that's not the case this semester. So participation is going to be mainly, are you racking up penalties as far as contributing to your team? So you can lose participation points this semester by being super disrespectful and disruptive in lectures or in the Discord or Piazza. You can lose a lot of points, participation points. In fact, your participation grade can go negative if you do not contribute to your projects at a vaguely similar level to those of your teammates. In other words, we have new technology this semester that allows us to very closely track how much time each member of a team is putting into the project. If you have a slacker on your team, or slacker, I don't mean to say slacker, if you have someone who's not investing themselves to the same degree as their teammates, and there are many reasons that could be the case, right? There's a decent chance we're going to notice, and there's a decent chance that person's going to lose a lot of points, right? You're not going to get points if you are not contributing to your project, okay? So that if you are someone who contributes big time and invests yourself in your work and your assignments, that's really good news for you. That means hopefully your teammates will be as engaged as you are. But anyway, we can talk about this more later. Okay, extra credit. There are quite a few extra credit opportunities in this course. A couple of them are already visible on Canvas, and more will appear as the semester goes on. For instance, you can get a lot of extra credit points for participating in some of the game jams that Wolverine Soft puts on throughout the semester. And this is a fantastic opportunity. We'll announce them beforehand, in which you essentially get a lot of practice in, a lot of visceral practice in making additional games. So it's a super fun time too, and I encourage you to consider it. The average grade in this course historically is an A, a very, very low A, almost an A-. Okay? This course does not have exams, I always found it frustrating back in the day when I would pour my heart and soul into the projects and love them, but I would just struggle with exams. I would blank out. I would get anxiety on exams, and so that brought my grade down a lot, often in many courses. Not the case here. It's not going to happen. If you invest yourself in your projects, if you listen to feedback, you will almost certainly get a very, very great grade in this course. However, this is not to trivialize it. You will be investing a lot of time, but you will be handsomely rewarded for your investment. Okay, not just in terms of grades, but in skills too. So please look forward to that. I do. Grading process. Okay, games are often seen as fairly subjective things. One of the ways we get past that is we try and have a very specific rubric that points out things you must have. You must have meaningful decisions, and we have a definition for meaningful decisions we'll talk about later. You must have juice, right? You must have guidance. But another way we do this is that when it comes to the bigger projects like P3, where many of the points are in this course, we average your grade among the instructors who grade it. So 3 or 4 instructors will be grading these together, and we will average those grades, okay? So that's one way we try and get past any one person's bias toward a certain genre or anything like that. And we try and be as unbiased as we can when we focus on the rubric and what it says. There's a collaboration policy in this course, and it's a little bit different from other courses. Tutorial 1, Tutorial 2, and Project 1. So the first few weeks of the course, no external assets are allowed, no sharing of code, no copied assets from the internet or anything like that. Just to, well, it's so we can't have you do that during these early projects because you're all working on the same stuff, and we really want you to get up and rolling quickly with Unity and your technical knowledge. Later on, however, when you're working on different projects, such as when P2 starts, you're working on your own game, or P3, you have your own game, then sharing assets is not quite the same big deal. However, we always need you to credit things that you didn't create yourself, okay? And I'm thinking about this. On Tutorial 1, it's okay if you brought in something from the internet, since you're not, for like a texture or something, or an asset store creation, you're not going to publish those. You're not going to commercialize those. Your P3 is going to go on itch.io. So we need to be careful about that. But anyway, you always want to be crediting any external assets that you use. Okay, it's simply respectful, and some licenses require it. We check cheat detection on these early assignments via standard MOS, which is an MIT software for cheat detection, and another solution that I won't tell you about. Okay, and we usually find like 1 or 2 teams per year, unfortunately, that violate this rule, and the result is not great. In other words, you may discuss general course concepts with anyone at any time. You may share example projects or kind of toy experimental projects, and you can share that code. You can discuss assignments at a high level, and you can share code for implementing general concepts. You may not share project-specific code, at least on Project 1, Tutorial 2, okay? You may use external assets, but only in small quantities. We do not want you downloading an entire game to turn in. Only if most of your project's assets were created by you, only if you document your usage. So in your code, you might put in a link to where you got the code if you used external code. Or you might create a credits.txt that includes external images. If you have a license for the assets, and also please ask us if you're confused, okay? You can always ask us, hey, can we use this? And we'll say yes or no. Anyway, I want to give you about 30 seconds, chat, to ask some questions. We moved fairly fast. I want to give you 30 seconds to ask a question, so go for it. I think Twitch is a little bit behind today. How are you today? I'm doing fantastic. I couldn't be doing anything else. I could be anything any else than fantastic while streaming about this topic. It's so fun. I got a question about office hours in Discord. Would there be a queue for students or everyone just chat for questions? So the way we've set this up, and we may change it, is that if you go into the Discord server, you'll see that there's like a waiting room for the office hours. And then there's like a private room for office hours. And the idea is we'll all meet in the waiting room. And if we need to talk about something in private, the instructor will jump into the kind of locked voice channel, and then they'll bring in the one person to talk privately, and then they'll kick them out and go back to the waiting room when done. So that's how that will work. So there's not a formal citation process. We can just kind of throw some links into comments and call it good. So that's okay. There's actually... So the formal process for this is to create a credits.txt. You probably won't get dinged if we can find comment where you put some code. But in general, you want to have a credits.txt. And I think some of the assignments, and definitely the syllabus says this, that if you use something external, create a credits.txt in your submission deliverable, and just kind of quickly put a link to whatever you grabbed and who made it. Okay, and that'll be fine. Will the Unity Hub template cause any problem? I'm not sure. I know of a template for Unity Hub. I'm not sure what that means. Is it bad if we don't know any external assets at all? So if you don't know any external assets and you didn't use any, then you're good to go. You don't even need a credits.txt because you made everything yourself. If you brought external assets into your project and then forgot where they came from, that is a tough problem, and that is actually a problem that real deal studios run into. One thing that Arbor Interactive does, for instance, my studio, is that we'll often, when we're prototyping something, we will often go to the internet, just Google image search, and just grab the first thing we see and throw it in. It's just prototype, right? It's placeholder. It's not going to be released. It's not going to be commercialized. It's going to be okay. But that stuff needs to be replaced, and you need to know that it wasn't created externally. And so that's sometimes a problem. Like, you don't want to forget about that. One thing you can do is if you use like images, you can use Google reverse image search to usually find the source of whatever you used. That can be a tip for that. No, there's no requirements on how credits.txt is written, so long as you just put some way for us to find the original source and figure out like who the original source of this asset was. That's the only thing that we have to be able to do as instructors. That's it. Okay, let's keep going, team. So, a question for you: what is a license? Right? In this course, a license actually matters because you really want to have a license for the assets. We kind of require you to. In other words, if you put a picture of Mario in your game, what we'll do as a staff is we will deduct a 20% penalty from your grade, and we'll ask you, hey, we will remove this penalty. All you have to do is send us confirmation that Nintendo gave you permission for this. Right? Nintendo does not just freely license their characters out to other studios to use in their own games. So please be careful. In general, we might not apply the penalty if it's not a final deliverable, but we'll tell you in your comments, like, you need to remove this or you will be hit with a penalty next deliverable. Sometimes that's how it happens. What is a license? If you go to a GitHub repo or a GitLab repo, you'll often see this. You'll see this kind of thing, but you'll also often see a license.txt. Okay, and you might not have paid much attention to this, but you should start doing though. This license.txt is kind of the creator's wishes for what you can do with this software. Okay, you can read it, and it might tell you, like, okay, permission is hereby granted free of charge to any person obtaining a copy of this software to deal in the software without restriction, including limitation of rights, blah, 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 blah. Basically, you can do anything to this software. But you can't sue the person who created it, right? Because this software is coming without any warranties. This is a really good license for our course because this would allow you to use the asset in your academic games. It might even allow you to sell a game with this asset in it. So OpenVPN, open source assets, public domain assets, OpenCV, the computer vision library, right? OpenCV is released under a BSD license, and BSD is very permissive. It basically allows you to do anything. Open source initiative. Da, 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 da. I think this tells you what BSD is. Here's the rub. Okay, here's the thing you need to take away. When you grab an asset online, there is, you have to ask yourself, am I allowed to have this? Has the author of this asset given me permission to use it in my academic game? And if you've gotten an open source asset or a public domain asset, chances are the answer is yes. One excellent source of free and open assets for you is opengameart.org. If you go to this website, you'll find very permissively licensed textures, sounds, 3D models, and stuff like that. And almost everything you can find on this website, you can use in this course. So public domain, right there. It's public domain. You can do anything you want to it. You can edit it. You can include it in your game. You could sell it later if you want to. So anyway, but the real takeaway is, if you have any questions on this topic, please ask. Can we use this thing? Can we use this thing? The answer is almost certainly going to be no to almost everything on Tutorial 1, Tutorial 2, and Project 1. On P2 and P3, that changes a lot, okay? So participation. Must I attend every lecture? Yes, is what I would say during a normal semester. However, this is the COVID semester, totally remote and virtual. Must I attend every lecture on time? Yes, is what I would say. You do not need to do that this semester, okay? Why should you care? There would have been a 20-point penalty. Attendance, blah, 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 blah. If you have an excuse, okay. None of this really matters because this is a remote semester. You do not need to participate in the live lecture if you don't want to, though I do recommend it. You can ask questions better that way. And it also builds up discipline, which keeps you on track with assignments and all that. Must you attend every lecture on time? The answer is no. You can watch the recordings on YouTube. You can watch them on Twitch while they're there. And the links to both of these things are on Canvas, okay? So don't worry about that. When are things due? They're almost always due as lecture is beginning. So at 11:30 a.m. Eastern Standard Time is when assignments are due this semester, okay? And that really does not matter where you are on the globe. That is the time it's due. That might be later at night for you. That might be in the morning or afternoon for you too. So please also keep an eye on Piazza and Discord. Please check in on those things at least once a day. We will occasionally send out things like polls and surveys and forums that we need you to fill out for the course, and sometimes pretty quickly, okay? We'll try and give you a bit of warning, though. Okay, let's talk about the late policy real quick. It's a relatively simple one. If your assignment is turned in late at all, if your assignment isn't turned in late, you just get the score you were going to get, okay, your graded score. If you are less than 24 hours late, then we return your graded score times 0.8. So you're 20% off, okay? And that's a big deal, okay? It's not the end of the world, but you do not want to get this penalty. And then if you are more than 24 hours late, if you're 24 hours late or more, then you will get 0 credit. We won't grade the assignment, all right? You must avoid this result, this fate at all costs. And you can do it, but it does require planning and organization. Okay? The official timekeeper for all of these decisions is the Canvas timestamp. Okay? If your assignment is 1 minute late, as cold and as harsh as it is, that's how it goes. You're going to get the penalty. Okay? So please know this. It's very consistent. And because of that, build up habits and build up a discipline and a plan to always make sure something gets turned in before the deadline hits. All right? What if Canvas is down? We will excuse it only if it is a widespread outage. Okay? So if you're having Canvas issues because your Wi-Fi is slow or because Canvas just isn't working, but only for you, that's not going to be good. Okay? Canvas can take a long time to upload. You must plan and budget for this. It's your responsibility. You can do it. Okay? So please submit early. And I don't mean 10 minutes early. I mean at least an hour early, and probably more than that. Submit the day before the deadline, okay? So any questions? I'll give you another few. I'll give you another 30 seconds, chat, to ask some questions. So another question: does this licensing issue extend to the remake that we're making of Metroid or Zelda? The answer is no. So we will be providing those assets for you. You won't have to go out and get them, I think, for the most part. And you are allowed to use those for this remake project. These projects will not be published on itch.io or anywhere else, and they are going to be used purely for an academic purpose, so we will allow them in this course. I'm not a lawyer, this is not legal advice. There's very low chances of an entity being annoyed at this. Because of the fact that we're not making these projects widespread, we're not selling them, and it is for an educational purpose. So, okay. So let's keep going. Resources. So there are many resources for you. Though it can be hard to find them sometimes, and harder still even to get the motivation to use them. Office hours, super valuable, right? And you can check Canvas to see when they are. Please, please, please go to them. We can offer you tips and strategies and techniques. Even if you don't have any questions, we can speed up your dev process just by talking and conversing, okay? So please come by, especially if you're having problems, if you're not feeling great, let us know about these things. It allows us to teach you a lot better, okay? So in this course, there's a chain of help. I want to tell you a story, okay? When I went to Electronic Arts, I joined the team, and it was really, really hard because we were at the end of the Sims 4's development period, which had lasted about 5 years. And this was a code base that I think had about 5 to 6 million lines of code in it. I'd never seen a code base this big. And so the question was, well, how could I fix any bugs? How could I implement anything or make any impact when I didn't know what was going on? For a while, I thought that I could just read the code and eventually understand what was going on and then solve the problems. However, this was extremely misguided. There was too much stuff. There was many lines of code. There were too many systems already in place, right? It was hopeless, and I wasted a lot of time. I discovered that the best thing to do is spend a little bit of time trying to fix it yourself, and then you go and reach out to help, and you get progressively more sophisticated in who you reach out to, okay? In other words, when you're trying to fix a bug in a system, in a game with 5 million lines of code, you go out and you try and find the person who owns a certain system, right, rather than the system itself in code. In other words, programming on a big team, as you will discover, is much more social than you might realize. In this course, there's a chain of help. When you are confused, the first thing you should do is you should spend like 15 minutes. Spend 15 minutes trying to fix it yourself. Then here's what you do. You set the timer, 15 minutes is up, okay? You start Googling. Then 15 minutes is up, and you post to Piazza. Just do it, okay? Just post to Piazza, I'm having this problem. Has anyone seen this before, okay? The reason you do this is that you post to Piazza so that there are now 2 threads running, both of them trying to get your problem solved. You are still experimenting and trying to figure out why the code has the bug, but you also have a team in the cloud, right? Your peers working with you to try and solve it too. If either of these threads succeed, you move forward, okay? Whichever one's faster. You start working on a different issue, maybe. If you're getting really blocked and wrecked by a bug or a problem, you just can't figure out how to implementing something, post to Piazza and then go work on something else. Let the Piazza thread work for you, okay? And also, your most challenging issues, don't work on them alone. Bring them to office hours. If you're really stumped with something, then just pouring hours into solving that problem yourself is a really poor use of time. It's extremely inefficient. You do not have much time in this course, and you must understand that. So you run into a big issue, it's blocking you, it's eating up all your precious time that you need for other stuff. Write it down, put it aside, go work on other stuff that you can do efficiently. Then bring that nasty problem to office hours. We can knock that out together and make that problem extremely efficiently solved. Okay? So anyway, just to reiterate, you really need to think about your time as a resource in this course. You are given a lot of work in order to stress your time management and efficiency skills. Okay? That is the point. So keep this in mind. Do not let something block you for too long. If something's blocking you, put it aside and then go and get help to knock it down in no time flat later. All right? If you need to contact us, there's private correspondence, EECS494staff@umich.edu. You can also send a private message on Piazza as well, okay? There are lots of other means of getting tutoring in this course while you're taking this course. Wolverine Soft meets, I believe, once a week, and they have a ton of spectacular students who already have a lot of Unity knowledge and game design knowledge, and they can definitely share some of that knowledge with you. IGDA Ann Arbor happens once a month. If you're interested in talking with local and industry professionals, that could be a great way to get some knowledge. I don't think we're going to do public game night this semester. We used to do one, but that was basically a de facto office hour that I did once a week, an extra one. If you are feeling anxious, if you're not feeling good, you feel like everything's falling apart, please don't keep it to yourself. You can contact CAPS. You can also contact us, okay? Anytime on any topic, all right? So please keep that in mind. We're here for you. Your safety and health is our number one concern. You can't learn, you can't have an impact if you're not taking care of yourself, okay? So we'll help you with that. EECS 494, rule number 1, and I'm going to move my little box here. There you go. The rule number 1 of this course is you must communicate, okay? Do not keep your problems, do not keep feedback or discomforts or struggles to yourself, okay? We cannot help you with problems that we do not know about. So you must let us know, and you must make contact, okay? We might not be able to solve every problem, but we can't even start to solve a problem if we don't know about it. So make contact. We will help you out, okay? Let's move on. Logistics are not something that's very entertaining and playful. This is a game dev course. It should be fun and interactive and playful. I'm going to give you a little bit more time, one final 30-second period chat, and then we're going to take our 5-minute break, okay? So 30 seconds of questions, and then I'll probably hang around and ask more. Let's turn the music on, 5 minutes. Okay. Okay, 5 minutes. When we come back, chat, we're going to move very fast, okay? I think I took a little bit longer than I wanted to on those logistics, okay? So we're gonna get moving very quickly. Yes, I actually faced, thank you for the music compliment. I actually faced some criticism early on in my lecturing career because I played pretty much exclusively Donkey Kong Country music. And so we have diversified our selection of tunes. How are we going to do the final project showcase this semester? Go to 494showcase.com. 494showcase.com. I'll put this in the chat. Yep, Ish has it. Essentially what happened was we created a showcase website where every game was displayed in like a tile pattern, and at the very top was a tile that was actually an embedded Twitch stream. And so this was a way to kind of bring back the real-time, interactive, like live feeling of the event, right? Like you're in a community, lots of people are playing at once, right? And make all the games super easy to play. There's also a voting tab at the bottom of the website where you could click and vote for your favorites. And there's also a Discord server that at the very top that was dedicated to like giving feedback and interacting with the student dev teams. The Discord server for the event had one channel for each game, and people poured feedback in, and it was just fantastic. It was extremely successful. We had a 1.2K impressions that night on these games, and quite a few of the games actually on their itch.io page, they had comments that were left. So people were definitely playing these games and giving real deal feedback. It was so much fun. I forget what's next on the playlist. Ooh, oh, this is a good one. You may offer suggestions if you would like to have music. However, this is not a democracy. So I cannot guarantee it will be added. Okay, chat, we've got about 60 seconds left in our break. So the question is, what is this song? What does it sound like? Is this Final Fantasy XIII? It is. Well done. This is the boss music called Saber's Edge from Final Fantasy XIII. A game that has a lot of incredible music. A series that has a lot of incredible music. Okay, chat, we're back. We're back from break. And I want to talk now about more technical topics, things that can get you up and running quickly on some of these projects. Could be very, very useful for Project One. The first thing that I want to talk about is the topic of input management, how it works in Unity. There are a few little gotchas and things you'll want to consider. So let's say you've got a game here. You've got your Rollerball release, and people are liking it. However, there's a problem. There's a problem because your players don't want to use the keyboard. They want to use their controller, okay? They want to use their DDR dance pad, their old Nintendo 64 controller with a USB adapter, all right? Well, how do you make sure that no matter how you program your game's controls, it's just going to work, okay? One of the things that Unity gives us, and maybe I'll make myself a little bit smaller, I don't want to cut off some code. One of the things that Unity gives us is this, an abstraction, input.getAxis, okay? If you look in Unity, it's actually possible to do input.getKey, which will test whether or not you are pressing a key on the keyboard. However, you can also use the concept of an axis. An axis, essentially, it's a very high-level term for doing something in a game. For instance, horizontal, instead of, is right arrow key, pressed, it's like, okay, what is the value of the horizontal axis? Instead of up or down arrow key pressed, what is the value of the vertical axis? It'll be 1, 0, or -1, right? And there are axes for firing, there are axes for jumping, and other stuff like that. And the cool thing is that Unity will automatically map this this piece of text, horizontal, vertical, jump, fire, whatever. It will map it to the inputs of the controller that's currently plugged in. Okay, this is a really cool example of what power game engines give you. They give you the ability to focus on the game design and not the super low level topics of, okay, how does Windows or Mac OS X check and pull input systems for devices plugged in, right? So anyway, I want to show you something. Okay, here is a version of Rollerball that I did for a summer camp actually in Shanghai, and it's a unique game. It's a little bit different than the normal Rollerball. Okay, you can use the arrow keys, right, to move around, and it's programmed in just the way that you saw. It just uses the axes, right? Okay, we can roll around our little watermelon character here. Okay, now let's go ahead and do this with something else. I have right here an Xbox controller, Xbox One controller. All I do is plug this in, the exact same code, because it uses axes and kind of high-level API there. It works, right? It just kind of works. That's not very exciting, though. Chat, riddle me this. Do you know what controller this is? Have you seen a controller like this before, chat? I'll give you a hint. You probably have you heard? I'm guessing you've heard of Sega, right? Sega. It is the Sega Genesis controller, the famous Sega Genesis controller, and it has a USB end. So let's go ahead and plug this in. And I wonder if our modern game will work with the Sega Genesis controller. Aw, yeah! Genesis does. Let's rock. Go, 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 go. Oh. Ah! Talk about adding strange game mechanics to your rollerball, huh? So anyway, that's some of the power of a high-level kind of abstracted input system. Now this is not super important. I do recommend using it though. You can use other input functions. You don't have to use getAxis. You can use things like getKey if you want to know the specific state of a key, whether it is currently pressed down or not. And then use key code enumeration to figure out which key you want. Right arrow, up arrow, it's got all of them. By the way, you do not want to put your input-related code into fixed update. In the tutorial, it actually does this, and it's incorrect. You want to put this into update, not fixed update. The reason is that Unity has various threads in it, and the physics thread, which is represented by fixed update, runs it's desynchronized from the update thread, which is like rendering and input polling. So since input polling is done on the update thread and it's not synchronized with the fixed update thread, the physics thread, what can happen is, you enter an input and it gets picked up in the render update, right? So in the update function, it gets picked up. However, the fixed update might not run on that frame. And so what'll happen is that input goes away and fixed update doesn't even notice you ever did it. So that's why sometimes the jumps are missed. Some of the rollerballs that were posted have this issue. You don't need to fix it. For future assignments, you will, though. Okay, how does Unity know what you mean when you say horizontal, vertical, fire, jump, whatever? If you go into Edit, Project Settings, Input, you can actually customize what axes exist and what keys and inputs they map to on a device, or what letters on the keyboard, what keyboard keys it maps to, okay? Yeah, that's an example of using that. However, look at this right here. It's get key down, okay? Many things in Unity come in threes. Okay, you might have seen input.getKey, but have you seen input.getKey down? Have you seen input.getKey up? Right? These are three different functions that do three different things. Okay? So the first question for you should be, how do you find these docs? Unity has incredible documentation online for essentially every function within its system. And the simple answer is you can almost always, because of how great the Unity community is and how great its documentation is, Google Unity and then whatever topic you care about. Unity input get key, okay? Unity input is fine. A question that you care about now is what are the differences between these functions? You will almost certainly be using these functions on your project 1. Get key is a function that just lets you know when you call it whether or not that particular key is held or not. It's a Boolean function, so it will give you a true if you're holding down the arrow key, and if you release it, it will start giving you false, okay? Here's an interesting one. Get key down. Was the key pressed down on the current frame? Okay? This is the question of, did the user press down on this frame? Not has the user been holding it down. Okay? It's not the question of, is the button currently held down? It's the question of, was it pressed this frame? This is a really great function for like one-off, boom, instantaneous inputs and mechanics, like a jump button. Okay? When you're jumping, you usually don't care if the button is currently held down. You care if it was pressed this frame. Okay? So get key down will give you that. Get key up is the opposite. Get key up will return true only if that particular key was released this frame. Otherwise, it gives you false. It gives you false if you're not currently pressing the button. It gives you false if you are currently pressing the button. It will only return true on the one frame of the game on which you release the key. Okay? This can be extremely useful if you're implementing something like variable jumping, where you jump, but if when you release the key, your character starts to go down, right? So you jump, and then if you ever detect a get key up on the jump button, you just take the velocity, set it to 0, and you start falling down, right? You might be wondering, particularly if you don't play a ton of games, and that's fine, what is a frame? He keeps talking about a frame or an update. So a frame is essentially a refresh of the game's rendering, and often the game's internal state as well. Games are usually rendered at 30 or 60 frames per second, as opposed to 24 frames per second of movies and most TV, okay? So here's an example, right? Film is 24 frames per second. A painting would be 0 frames per second, because it's just that one frame for eternity, right? So painting is 0 frames per second. Film gave us 24, right? And you can see the difference here. So 60 FPS is very smooth. 30 FPS is still pretty smooth, but you can see it's a little bit choppier. And 15 FPS is much choppier, okay? Another thing that can happen is when your game has a lot of stuff going on, when it's doing computationally heavy stuff, or maybe you wrote some code that's inefficient, or it's trying to render some fancy graphical effects, what can happen is you get frame lag. You get lag, and the game cannot render, your hardware cannot render the game fast enough to keep up with doing it 60 times per second. Here's a really good example of seeing this in action from the recent Mad Max game. Beautiful game, it's running pretty smoothly, right? 60, very, very fluid and smooth, right? Still pretty smooth. Here comes the dust storm. Ooh, oh, it's moving in slow-mo. It's a slideshow. Ooh. Oh, it's very slow. Okay, now it's a little bit smoother, maybe. So, when it comes to frame rate and frame consistency, you really want to avoid this because it ruins the feel of the game. It starts to feel sluggish and sloppy, you miss inputs, and players really do not like that, okay? So think about the use cases for all three of these. Ask yourself this: if you're planning to work on Zelda, if you press the attack button, the sword comes out, right? Boom. But if you hold the attack button, what happens? Does Link continue to do the sword? You need to be accurate in your recreation of these games. So this is actually a question you should ask yourself, and then go find out, do some research, and then you should choose one of these functions to use, okay? So let's go ahead and keep going. I want to talk about other topics beside input. So let's keep going here. I want to talk about the topic of colliders and triggers, because this is actually a very confusing one if you're just very new to Unity, okay, and game engines. So rigid bodies and colliders. These are both components, okay? And you've actually used them both. If you go into your rollerball, for instance, and look at your player game object, it's going to have a rigid body component, and it's going to have a collider. If you click on it in the hierarchy and then go to the inspector, you'll find these both. And you can see they're both very different components. They have different properties. One has a little trigger checkbox, a material, can center and size. One has mass, drag, angular drag, use gravity, all this other stuff, right? However, they're very related. They both relate to physics and how collisions work, okay? So what I want to do is I got a little challenge for you, okay? So here's the challenge. Let's say we've got a game, and chat, I'm going to need you to give an answer on this one. Let's say we have a game, right? It looks like this. We got a ball, we got a piece of ground, and here's what's on the ball, okay? The ball has a transform. It has a sphere mesh filter, so it's some component that holds the vertices for the sphere, and then a component, the mesh render, that takes those vertices and renders it to the screen, okay? Now, we've got a piece of ground here. We've highlighted the ground, and let me go ahead and get out of here. It has three things as well. It has a transform component, it has a cube, a mesh filter, and it has a mesh render, okay? And so the question for you is, when I run this game, what is going to happen? So what do you think will happen, chat? You can go ahead and type in some answers. We've got a nothing. Nothing will happen. Nothing. There's no rigid body. Oh, very nice. Nothing. There's no rigid body. Let's find out what's going to happen. Hey! Well done, chat. Well done. Nothing happens. There are components, right? There are things related to rendering, so we can see both objects, but there isn't any other component that would actually cause something to happen in this game, okay? A rigid body gives a game object physics, okay? However, a collider component gives a game object collisions. You can have one without the other. And in this case, we have neither of them, okay? So I've got a new challenge for you, okay? Look at the changes we've made. We've given the sphere a rigid body. We've also given our ground a rigid body. So the question, chat, what do you think is going to happen? Problem solved, right? The boss walks in, wants a fix now. So, okay, boss, we got the rigid body on. We're good, right? So I'm seeing the ball falls through the plane. I'm seeing the ball floats. I'm seeing that there's no gravity in space, which is true, but I'm not sure it's so relevant right now. Both fall. Interesting, both fall. Oh, well, we'll have to see what happens. Ah! Okay, chat, here's the question for you, a philosophical one. Are these two objects falling, or is the camera going up? Maybe it's not so relevant to us, but yes, you are correct, chat. In this case, both objects are falling. Well done. Okay, that's not what we wanted, so we made a change. Okay, we don't want the ground to fall. We want the ball to fall onto the ground so we can start playing, right? Okay, so we got rid of the rigid body on the ground. So the question for you, chat, what's going to happen? Problem solved, right? Give you a little bit of time to type your answers, chat. The ball falls through the ground. Are you sure? I mean, the ball... well, we'll have to see. I thought I did a good job here, but we'll have to see. Look at this. Whoop! Yep, there it goes, right through. Well done, chat. Well done. All right. You're doing an excellent job. I'm very happy. Okay, so I made a change. Okay, this time we got it right. All right. So what's going to happen? We added the box collider to the ground. What's going to happen, right? It's gonna collide with the ball, and it should stop the rigid body, right? So you'd be surprised how often these kind of bugs come up, where things aren't colliding, they're not detecting stuff right. The same thing will happen because the ball has no collision. You are absolutely correct. Well done, well done. Again, the ball can fall because it has a rigid body, right? Things can collide with the box collider because it has a collider. However, nothing can collide with the ball because it does not have a collider on it. In other words, Unity recognizes that this sphere is a physical object, right? It moves, it has gravity, it has velocity, but it has no collider component. So the physics system, NVIDIA's PhysX, which Unity uses under the hood, has no idea how this ball is supposed to collide with anything, so it just goes through everything, right? Like that. Okay, we've made a final change, hopefully. We got a rigid body here. We got a sphere collider on it. So we got physics and collisions for the ball. On the box, we don't have physics, but we do have collisions. What will happen? Hey, all right, finally we got there, all right? Okay, so remember, rigid bodies give physics properties like acceleration, velocity, angular velocity, all that drag to an object. A box collider, a collider, sphere collider, any collider gives collision, enables collisions for that objects. So very often you will want both, but not always, okay? So here's a question for you, chat. What is wrong with this game? I'm going to show you this game right here. There's something very wrong with it. And I'll help you out a little bit. I'll give you a hint, okay? Look, it's rollerball. We're going to go collect some stuff, right? Let's do it. Let's go collect this coin. Oh, okay. Oh, jeez. Okay. Okay, hold on. All right, let's grab another. Let's grab it. Okay. Ugh. Oh, jeez. Oh, this is painful. Ugh. Yeah, see that? Ouch. Okay. Okay, hey, chat. What's wrong with this? What do you think, chat? I'll give you a little bit of time to say what you think is wrong with this, how that just played out. Well, that's not necessarily a problem. So chat is saying that the object has a collider. But the thing is, if the object didn't have a collider, we could not grab it. So currently, right, if you look at the colliders in the other, so let's go ahead and get out of this. If you look at the, if you look at the other colliders, right, like other objects, these objects have colliders, right, and they have physical collisions with each other. The ball hits the object, it stops cold, right? That's what we would want. However, in most games, when you're collecting stuff, you don't want the collectibles you grab to halt your momentum. You want to detect that a collision happened, but you don't want to have the physical ramifications, the physical impact of that collision. You just want to detect that the collision is here, okay? So this is what we currently get with colliders, okay? This is what we get with a collider that is set to be a trigger, okay? Look at the top. This is a box collider on these collectible objects that does not have the isTrigger checked. If you check that isTrigger, suddenly no physical impact will occur. However, the collision can still be detected. And this is code that you wrote, right, on the left here. This is code that you may have wrote for the tutorial 1, okay? Notice you have onCollisionEnter here and a collision data type coming in when you have a normal collider. However, once you check this isTrigger box, now you have an onTriggerEnter function. You need to make it onTriggerEnter instead of onCollisionEnter or it won't be detected. You also need to change the collision input data type to collider input data type, okay? Otherwise, the code can work essentially the same. This is a bug that gets people all the time and it makes games feel very poor. So if you feel like collecting stuff or collisions in general just aren't quite working for your game, this might be a reason why, all right? So those are the changes you need to make. You can revisit this lecture if you find you're having this problem, okay? So here's just a general note for Unity. It may seem very odd at first. In Unity, if you give a function a certain name and a certain input type, right, or a certain parameter list, right, a signature, then it will get called at certain times. Unity will call it automatically during certain moments, okay? So for instance, if you have a function called onTriggerEnter in one of your components, in any component, if you have a function with that name and that data type, then it will get called when you collide with something. That's a trigger, right? Same goes with a function like update. If you have a function with a void return type and just the name update with a capital U, okay, do not miss these capital letters or you'll be very frustrated. Then it will get called, update will get called once per frame. onTriggerEnter will get called when a trigger collision happens. Start, same way, right? A question you might be asking yourself is, how am I supposed to know what kind of function names I can use to get these special activations, right? You can look this up online. Do a Google search for Unity monobehavior, and you'll find that these messages, right, these functions are special if you put them within a monobehavior class. If you recall, monobehavior is the type that all of your components derive from, okay? So that's why those messages will get called, and that's why you should look up specifically, Google search Unity monobehavior to learn more about that parent class. One cool thing is that in functions like the collision functions, onTriggerEnter, onCollisionEnter, and there's some other functions that have this too, you will often get an input data type, right? This input data type is usually given to you so that you know more about the nature of the event that just happened. So if you want to know who I collided with, you can use other and then .gameObject. It has a .gameObject property, and then it has a .compare tag function. So you can check the tag of the thing you just touched, and you can do execute logic based on that. If it was a different tag, like an enemy or a spike or something, you could end the game by checking whether that object has a spike tag or something like that. So there are a few different kinds of collision-related functions. Much like inputs, we often come in threes, right? So we got onCollisionEnter, we have onCollisionStay, and onCollisionExit, right? How do we find these docs? You would Google Unity collisions, right, or Unity monobehavior. What's the difference? I want to move faster, so I'll kind of tell you. onCollisionEnter is a function, much like you see right here, onTriggerEnter in this case, that will get called during the first frame in which you touch something, okay? The first frame in which you come into collision with something. It will not execute again if you stay within that collision. If you stay colliding with something, it won't happen again, okay? So, however, onCollisionStay is a function that will be executed every frame in which you are still contacting something, okay? onCollisionExit will execute during the one frame in which, okay, you're colliding, stay, exit. Okay, so here's how it goes, the life cycle of collision events. Okay, no event, onCollisionEnter, onCollisionStay, onCollisionExit. Okay, no event. That's how it tends to go. Okay, and this is really important, particularly on your Project 1, because there's a very funny class of bugs that you will get into if you do not use several of these, okay? Okay, I don't have any GIF to show you this. Here's an example. In The Legend of Zelda, often students will implement the take damage component by doing onCollisionEnter or onTriggerEnter. So hey, it makes sense, right? If my player object, which has a can take damage component, collides with an enemy object that has like a can deal damage component, right? You use onCollisionEnter to detect that and deal some damage to whoever has the can take damage component, right? So the player in this case. However, if you only use onCollisionEnter, there's a bug the player can do where if they touch the enemy, they'll take damage, but if they can stay contacted with the enemy as it walks around, they will never take damage again, which allows them to defeat the enemy so long as they maintain contact with it without doing any damage at all, right? So what you want to do in Metroid and Zelda is you'll want to use both onCollisionEnter and onCollisionStay to detect and deal damage if you need to, okay? So it's a very common bug. I'm sure we'll be seeing it this semester when we grade and give feedback. Okay, so what's this? We already talked about it. This is Unity sending in data to you so that you know who you're colliding with, what what is the context of this event that just happened, all right? So make sure you use code completion or look up the docs online to see what kind of interesting information you can get. For instance, their relative speed. That can be really useful if you want to do a realistic knockback, right? Something walks at you from this direction, you want to knock back that direction, not a random one, right? Okay, so a challenge for you. What does this script do? Any ideas? So you probably don't need to put a rigid body on the coins. You can probably just have the rigid body on the player and then detect that you've collided with the trigger of that coin. No, but that's a really great question, Cube Legend. The life cycle is this. They're coming together, no event, on collision enter. Okay, that's the only event that gets called on that frame. And then, starting on the second frame of continued contact, on collision stay, on collision stay, on collision stay, on collision exit. Okay? So generally, on collision enter, on collision stay, and on collision exit do not get called on the same frame. Okay? Here, okay, so you've had enough time, chat. So on collision stay is a function that executes while two objects are touching each other, okay? And maintained contact with each other past that first initial on collision enter frame, okay? This is a really cool little function. What this does is it tells the object, hey, take your up vector. Every single game object has a transform, which has an up vector, a local up, a local right? So my up vector would be going out the top of my head. My right vector would be going out that way, or actually out that way, depending on how you're looking at this. And my forward vector, transform.forward, for me, the game object, would always be out of my chest. If I turn, then suddenly the forward vector points that way. If I rotate a little bit, suddenly my up vector is going at an angle into the sky, okay? What you can do in Unity, and it's amazing, is you can say, you know what? I don't care how you do it, but game object, set your transform.up to be a direction. So transform.up, make it go that way into the screen. And what it will do is it will rotate me automatically to point in that direction, okay? What this is doing is it's saying, okay, take the normal vector, right? So the normal vector between two colliding objects is the one that points out from the collision point. And set the transform.up to be that. And as a result, you get this behavior. You get slope behavior, where an object, a player character, whatever, will actually angle themselves as according to the slope that they're standing on. Right? So if they're standing on a slope, they'll make sure their up vector is going out of that slope. Right? So that gives you this really cool look. And this is used in platforming games to make slopes work a little bit better. So it's a little example for you. Without this component, we get this. This is how it looks if we turn this component off, because we're no longer setting our up vector to be coming out of the surface. We just roll off. There's nothing in our game now controlling the orientation of our object. Anyway, that's rigid bodies and collisions. If you're having issues with this, please come back and check it out, okay? We got one final thing that I want to tell you about. This one's really important for Project 1. We might continue this next week on Wednesday, because it's very important as Project 1 releases. Okay? I'll take questions after the lecture is done at probably 1:30, and we can go a little bit longer, okay? So, sequential mechanics. These are going to be very tricky for you to implement, okay? And here's what I mean by sequential mechanics. I'm going to show you two really hard things to implement, okay? So please be careful, and please ready yourself. This is truly terrifying. Ready? Okay, watch this, and make sure you've got the lights on in your room so you don't get too spooked. Okay, so watch this. Did you see that? Chat, did you see that? Okay, let's watch it again. I want you to watch the moment, what happens when the player goes through the second door to the left. Okay, so the player goes through this left door, and watch what happens. We're going through the left door, and that right there can be a lot of work. Very bug prone, okay? That transition is tough. Think about what's happening. The player walks into the door. That's a collision. We have to notice the collision, right? Turn off the player's controls, start moving the camera, right? Get it to the next area, turn the controls back on. That's a lot of things, and they have to happen in a sequence and over a period of time, right? And that over a period of time part is really tricky. Let's go ahead and take a look at another terrifying thing that you need to implement. This one from Metroid. Okay, watch what happens when the player walks through the door to the right. It gets me every time. Let's watch one more time, and I'll turn the sound down. We can talk about it. So in this example, much like the last one, I messed it up. We'll reload it. So much like the last example, the player gets to a door. The game has to detect that they've entered the door. It has to turn off player controls. It has to move the camera over a period of time to a new area. It has to re-enable controls, right? Move it over, new area, re-enable controls, okay? So this might not seem too difficult, right? Austin, I mean, what's the deal? Okay, this can't be difficult. Unfortunately, it kind of is. What makes these mechanics challenging to implement in a way you might not be used to? So here's how it goes. Player hits the door. You know how to do this. This is an on-trigger enter. You can write a script, put it on the door, have an invisible block in the door, give it a component that has on-trigger enter. Okay, you can do that. You can disable player controls. Just have a global static Boolean. In Unity, if you make something public static, you essentially have a global variable, which can be scary, and you shouldn't use too many of them, but they can be very useful too. We'll talk about how to make that safe later. Moving the camera over to the next area. You know how to move something. You know how to move your ball, so you can probably, from rollerball, you know how to move the camera, that means. And then you know how to re-enable player controls, right? That's just a Boolean, right? So on trigger enter, you know how to do that, right? Boolean, you can just set your player control enabled variable to false, and you can then set it to true later, right? And you can test this variable when you're in your input code to decide whether it should do anything. The problem is right here, okay? Moving the camera. You know how to move a game object, but you might not know how to do it over a certain period of time and then stop, okay? The problem is you've got a mechanic that is temporal. It exists and activates over multiple frames. The problem here is that your code does not activate over multiple frames. I'll turn my thing off so you can see, right? So on trigger enter, this all happens in one frame, okay? So imagine you're writing some code like this. Okay, on trigger enter, you detect that we just touched a door that is a western door, okay? So we're going to execute this function, perform room transition west, okay? We turn the player controls off. We move our game object over time, camera.main.gameObject, and let's say we got a function that does this, okay? Move a game object over time. We want to move the camera game object, and we want to move it over 2.5 seconds, okay? And then we re-enable controls. This is code we want to be able to write, but there's a problem. We can't write this code. We can't implement this function right here. Move game object over time cannot be implemented in Unity because Unity is actually single-threaded when it comes to scripting. Also, there's no way for us to actually pause this execution. What's going to happen is we run this function, right? Player controls get turned off. We then run this function, and immediately on the same frame, we turn controls back on. That's just not how it needs to work. We need this function, move game object over time, to take multiple frames. We need it to pause execution of this code. but we can't do it, right? At least not with what we know now. Okay? This line must pause execution of this function for 2.5 seconds. Thread.sleep is something you might have heard of. This will pause the thread, but unfortunately it will also freeze the entire game. So no frames will continue to execute. The current frame will pause, but that's not actually what we want. We want the current frame to continue. We want our code to pause. Okay? Unity is single-threaded, so we can't block on this thread. We can't create a new one. So there is a solution. You could create a state machine class that has a large amount of work, and we don't want to do it, very bug-prone. That's what I used to do. That's what I did when I took 494. Here's a good solution. For temporal mechanics and temporal execution of code, where we want to be able to pause code execution, we can use coroutines, okay? Coroutines are provided to us as a sort of feature of the C# language, but Unity also gives us some solutions for it. Here's how it works, okay? This is a coroutine right here. This piece of code will work. It is called awkward hello, and here's how it works. The start function begins, and we say, you know what? I want to launch a coroutine. Our coroutine is the delayed hello function. We know it's a code routine because any function that has a return type of IEnumerator is automatically a coroutine. This is a special return type in C#. Okay? Chat, what do you think is going to happen when I run this function? When the game starts, what is going to happen with this code? Chat, what do you think is going to happen? This might be one of the most important things to understand, coroutines. It will make so many things much easier for you to implement. So chat, that's enough time. I'll tell you what happens. Yep, you got it. What will happen is the game will start, and instantly in the console, you'll see hello, and then 3 seconds, 3 real-time, real-life seconds will go by. So it'll be like, hello, there, right? It'll be like that. It'll be that awkward. You'll see hello, and then 3 real-life seconds later, you'll see there appear in the console. Understand what just happened. You were able to delay execution of this delayed hello function, okay? Because it's a coroutine, you can now use special other functions like yield, right? You can use keywords like yield to say, hey, I want to wait, or I want to delay execution of this function until another function ends, or another another special class ends. So in Unity, what you can do is you can delay a coroutine by using yield. Okay, yield means you want this coroutine to wait for something. What do we want to wait for? We want to wait for 3 seconds, right? We spawn a new instance of the class wait for seconds, and this causes our coroutine to delay for 3 seconds, okay? Here's another example if this is a bit confusing. By the way, our course GitHub repo has a lot of examples on this topic that will help you understand. You can do experiments. Please check out this repo. It was made to help you learn these things quickly. Okay, here's another example, more complicated. I'm going to give you about 30 seconds, chat, to figure out what this does and tell me. Okay, 30 seconds, chat. What do you think happens here? This one's tricky, chat. Don't worry too much if this confuses you. It'll make sense. Okay, chat. So here's what happens. This is an even more awkward hello than before. When you start this, here's what will happen. Game start. Hello. There. So what happens is when this starts, we start a coroutine immediately. Delayed hello. Execution goes into delayed hello, and we instantly see a hello appear in our console. This coroutine, delayed hello, then yields to another coroutine. Yield return to another coroutine, which we're starting. Do humming. Do humming takes an integer 3. What happens is that immediately execution jumps to do humming. It goes into this while loop, and we see a appear in our console. Then we go down here and we hit another yield and await for 1 second. So this coroutine execution pauses here for 1 second. It then says, wow, okay, is number of notes larger than 0? It is. It's now 2 since it got subtracted in this line. It's now 2, so we hum again. So we print hum to the console and we wait for another second. Okay, that second passes. We go back to this loop condition. Are we larger than 0? We are. We're at 1. So we do hum again and wait for a second. The number of notes is now 0, so we break out of the loop. We get to the end of this coroutine, and we come back to the coroutine that was waiting for us to finish, and then we go and keep going, and we print there. Okay, so right? We go hello, wait, 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 break out there. Okay? So yield and yield return are almost always used together. Sometimes you use yield break if you want to end a coroutine. But generally, you can tell a coroutine to stop and wait for another coroutine. Or you can tell it to wait for a certain number of seconds. And so it's super, super useful. A question was asked in chat, is this spawning a new thread? The answer is going to be no, right? And I'll get you to an example there in a sec. So when you do start coroutine, it does not spawn a new thread. And that's really important to understand because you can lock up and get into an infinite loop. Chat, I'm going to leave you to do this one on your own time. However, this is code that will implement exactly what you need for a room transition. Okay? What happens is when this game starts, it gets into a polling loop. Okay? We enter into here, okay? See this while loop? We enter into the while loop, and then the game asks itself if we're holding space. If we're not pressing space, we jump down to here, okay? And I wish this thing didn't come up. And we just go around the loop. Yield return null, right down here. Yield return null is a line that says wait for the next frame, okay? Just pause for the next frame. Whenever you yield, you let something else run. So if we didn't have this yield here, nothing else would be able to run. We would just be going around in this loop forever. And because Unity is single-threaded, and this is not on a new thread, we would instantly lock the game. And that would not be good. So what happens is, if we press space, we grab our current position of us, we grab the final position we want to be, we store these in 2 vector 3s, and then we call this coroutine. This coroutine utilities.move object over time is over here. Okay, you can see it implemented over here. It is a function that moves your transform, whatever target you give it, and it moves it from your initial position to your destination position over a certain amount of time. Okay, it does this by calculating a progress variable that goes from 0 to 1 over the course of a duration seconds float. So progress will go from 0 to 1 over 2.5 seconds because that's what we passed in over here. And then it waits for 2 seconds, right? We move our object to our final position. It waits for 2 seconds, and then it moves it back, okay? So here's the result of this code. I press the space bar, and this happens. The camera has this component on it, right? This component is on the camera. So when I press space, it enters into this logic, and it does our coroutine. It waits for that coroutine to end. It waits for 2 seconds. It does a coroutine that sends us back, okay? So I want you to refer back to this code when it comes to implementing your room transitions. This will help you understand how powerful coroutines can do to implement mechanics that happen over multiple frames, okay? So another really useful thing that you'll probably want to use is a coroutine wait for enemies to be defeated. What you can do is if you yield on this coroutine, if you launch this coroutine and yield return on it, then your code will wait until this coroutine ends. This coroutine is an infinite loop that every single frame, it checks how many enemies are there. We can grab every game object that has the enemy tag using this function, GameObject.find game objects with tag. This puts all those game objects into an array of game objects. We can then check whether that array is 0. If that array is 0, then we know there are no enemies left in the game. No game objects with the enemy tag left around. And then we can break out. We can break out of this coroutine. Otherwise, we yield return null so that we let something else run. Let the game render, let other coroutines that are running run. And then we go around and check again, okay? So this is a coroutine that you can use to hold off on running some logic until all enemies have been defeated, right? You might use that for your custom mechanic or something. Here's a question for you, chat, and this is one of the final questions before we break for the day at 1:30. Why will the following code fail? This is a coroutine, okay? It is called intro icon after delay. So it looks like it does some UI work after delaying for a little bit, okay? You don't have to understand how exactly this coroutine works or what it's trying to do, since we haven't talked about UI yet. However, this code has a fatal flaw to it. This coroutine, remember, coroutines do not spawn on a new thread. All coroutines run on Unity's one single thread for scripts, for user scripts. Why does this code fail spectacularly? There isn't a yield in the right spot. That's correct. This code has an infinite loop. If you spawn this, if you call this normally, if it'll result in an infinite loop. If you spawn this as a coroutine, it will also result in an infinite loop. Why? Because this while loop right here never ever yields. This while loop runs forever and it never lets anything else in the game run. Okay? What you need to do is you need to, I think I put a fix-it thing here. It's missing a yield. You need to put a yield in here at the end of the while loop, probably yield return null. Remember, yield return null says, you know what? I'm passing. I'm going to yield until the next frame. So let's let everything else run. Okay? This is the fix right here. You notice we just put a yield return null in here. That means that even though this coroutine, its execution, is stuck in this while loop, this coroutine yields and lets other coroutines run. It lets other scripts run. It waits to the next frame. It takes a little break. Okay? Without this, it never takes a break, and it just dominates execution and never releases it for other things to run, ever. Okay? So anyway, I encourage you to go check out that repository that I linked earlier. And it has a bunch of examples in it, I believe, that will help you kind of understand how coroutines work. And please, you will need to experiment with this a little bit. You know, try removing yield return and just do start coroutine from another coroutine. That will actually use a coroutine to spawn other coroutines that can work in parallel. It's really cool. But anyway, so that is coroutines. Incredibly useful. If you're not using coroutines on Project 1, starting next week, then that you're having a very hard time. You're having a much harder time probably than you should be. Okay, coroutines make a lot of things much easier. We'll build some systems that use coroutines in the future, so you'll get an even better feel for how you can implement really powerful, centralized and decentralized systems with coroutines very quickly. So there's a little link to the repo here. What I'm going to do, we're going to talk about composition next week on Wednesday. It's very important. The idea of why are components a really great way to reuse code, a great method of code reuse for game dev and for other things as well. Why is inheritance not always a good option, right? Why is multiple inheritance so nasty? We'll be answering some of these questions on Wednesday. I'm going to post this right now to the... I'm going to grab the link here. We're going to post this to the... where's our schedule? Here it is. We're going to post this right in here. Minimize it. So feel free to jump in. I encourage you to jump in and explore, particularly go to the repo. The course repository on GitHub is just full of examples on various topics. It's also linked to from Canvas, so please visit it there as well. I'm going to stick around for about, I'm going to throw the music on, I'm going to stick around for about 15 minutes, and you can ask any questions you want, chat. Otherwise, good luck on Tutorial 1 and Tutorial 2. Please attend office hours if you're having any difficulties. Otherwise, I look forward to you posting your final T1 into the Discord. If you haven't played some of the fantastic projects that have been posted in tutorial in the EECS494 Discord, in the Project Progress channel, please check those games out. Offer your feedback. That is what this is for. And that is what we need to do as peers. Okay, keep all of our games getting better and better. Offer feedback. Okay? Anyway, thank you so much for tuning in, and I will see you all next week on Wednesday. Okay? See you then. Otherwise, Twitch chat, let's go. Let's get some questions. I'll turn some music on. What would be good? Okay, let me know, chat, if you've ever heard this song before. A magical song for many. Shout-outs to Wisconsin Badgers everywhere. This is not Video Games Live. It is, however, Kingdom Hearts. This is Hikari, also known as Simple and Clean in the West. Yes, that is kind of correct. It's the right way to think about it. Shine. So when you create a new, so when you have a coroutine and you tell it to yield, essentially it is saying, it's kind of like a processor going to rest, or a thread resting and letting everything else run. So if you took EECS 482, they have a threading library project where you do need to implement a way for a thread to say, you know what, I'm done. Go ahead and let something else run now. I think it might be called yield. Maybe it's called rest. It's been a while since I did that project. But you're thinking about it essentially the correct way. So progress is calculated based on time. That's a very, very good question. Let's take a look at the code again. This is Sean Kwan. Let's take a look at the code again. So in the final example here, if you look at the loop, it looks like eventually this while loop should still end. Even though it's an infinite loop, even though there's no yield break, yield return null, right? So there's no resting in this while loop for this coroutine. You would think that eventually it would end because progress is still being calculated over and over and over. But there's a problem. Time never actually advances. Time.time is always the same value because Unity's time system doesn't get a chance to run. Because again, Unity is single-threaded. in all of its scripting systems, which includes the time system. So time.time as a variable, it never gets updated, it never moves forward, because the single thread that could do that is locked in the while loop. If this while loop does yield return null, that means this coroutine is releasing to let something else run. It lets the time system run, which allows time.time to move forward, which causes progress to grow. Because of this, the loop eventually ends. Okay? And that's why. That's why. It's a very, very good question, though. You might think, if you're paying close attention, you might think the loop would still end. In fact, it does not. So, okay, everyone, what is this song? What is this from? Yes, J99 Dude was the first one to get it. This is Devil Trigger from Devil May Cry 5. This is the battle music that happens when you're playing as Nero and you get a really high rank. It's really, really cool. Different layers come in. I've still got time for questions, chat. Let me know if you had any questions, even on topics that were earlier in the lecture. Devil Trigger, like, this is one of those songs that definitely has the perfect amount of cheese. Just the perfect amount of premium cheese to delight. And it definitely does, so. Yes, so good question. JW Shin. So what happens when you yield return null? Essentially, it's exactly the same as saying yield return new, wait for seconds, like 2 or 3, right? Whereas that tells the coroutine system to wait for a certain amount of time in seconds. Yield return null says, you know what, just wait until the next frame. So it pauses execution of this coroutine until the next frame runs, at which point Unity's coroutine system resumes execution at the same place it ended at. In other words, like it is useful to think about the coroutine system as like a mini threading system with some very important caveats, right? It has the same result as a threading system in many cases, but in certain cases it locks everything up. It's like if you had a threading API, but you only ever had one processor and one processor core to run that API. So, in other words, it kind of simulates multiple threads with only one thread actually ever existing. Let me know if that helps, Jayshwin. Yeah, Wisconsin has a very impressive game dev scene. Madison, in particular, has a really it has some satellite studios. I think like Bethesda and Blizzard have a studio there. I think Activision, Raven Software is in Wisconsin. They have a large number of successful indie studios there. It's very impressive. I look forward to the day that Michigan has that same scene. We're working on it, so hopefully we'll be there soon. Yes, you may upload the web builds from this class. In fact, we encourage you to do so to your portfolio site. When you do this class, it will... so in this class, you'll be doing projects, and you should be using those to their fullest extent. Not only to get a grade, but use them to get internships. Use them to get further in interviews. Use them to delight your friends and family. However, you might want to be careful if you did use external assets. You'll want to make sure you have the license for those before you post the game, or you'll want to swap those placeholder assets out with something you created or something open source so that you don't get an angry phone call or an angry email one day from the rights holder of that external asset. Okay? So you will want to be careful about that. Do not post the code, though. Do not post the source code. Keep that to yourself. You may post the web build, the final product, for people to enjoy. Hey, Principles, it's good to see you again. I'm not sure who you are, but I hope that you were doing well. I hope the course served you well. Yes, your P1 final deliverable, your P1 gold deliverable, your P2 gold, and your P3 gold will all be required to be turned in via a personal portfolio. So if you already have one, you can go ahead and attach it to that and then submit that portfolio site, or you can create a new one. And when we get to those assignments and when you need to create that personal portfolio, we have some templates that we'll send you to. Just read the assignment specs. You'll get a nice template if you need one. So it's my impression that just about anything put on the Unity Asset Store is either paid, at which point you have a very permissive license to do stuff, except for like resell it. I don't think if it's not in the description on the Unity Asset Store, then you don't need to credit it in-game. However, if you use something from the Unity Asset Store, you must credit it in a credits.txt for the class. Okay? I think the general assumption with Asset Store assets, even free ones, is that you can use it in the game, probably without crediting. But if you're feeling kind and just want to be safe, you can credit anyway. I think that's probably a good idea, just to be safe. So my favorite game of all time is very hard to say, and it's constantly changing. I will say that the Resident Evil series is one I hold in very high regard, in part because it does an incredible job of building tension, which is what you want in a horror game. Building tension, but not through jump scares and cheap effects. It builds tension through just incredibly balanced resource management and resource scarcity. I really like difficult games. I really like it when they ask me to plan. And Resident Evil is a series that constantly asks you to look at what is available to you, right? Items. What routes are available to you? What's the safest route from one way to another? Is there items on that route? How much HP does an enemy have? How many bullets do you need to spend? Is it worth it? How many do you have left? Should you save now or should you wait and save your ink ribbon? Can you afford to tank a hit, or should you really lower your risk by using a healing item now, but at the cost of not having them when it might matter more and have more impact, right? So Resident Evil really builds this amazing tension, and every decision you make in that series just feels like it's just super impactful. So I really like that series. Otherwise, I like a lot of Nintendo games. I like Smash, as many people do. One of my favorite series is Guitar Man. It's not a series. Guitar Man by Enos, and I like their other games, Elite Beat Agents, Uenden Tatake, Osu Tatake Uenden, is a great rhythm series with a lot of charm and spirit. So that's a good series too. Yeah, I did enjoy RE5 and RE6. Like they don't have the same tone or gameplay philosophy as some of the classic titles and some of the remakes. That does not mean they don't succeed as an action game. RE5 and RE6 are particularly fun in co-op, but for different reasons than the old RE titles are. That's what I found. I've played League of Legends. I can see the appeal, but the introductory pipeline was not very good to me. I had an issue where I went through the tutorial as a certain character, and so I learned that character. And then in the very first match I ever played, that character was taken by one of my teammates, I think. And so I had invested a lot of time into a character, a lot of time. Well, I went through the tutorial on a character, and I immediately, in my first match that mattered, got forced to play a different character, and I had no idea what I was doing, and no idea what was going on. So I think the guidance kind of fell flat there. However, its staying power as a competitive game is, I think, all the proof you need that there's something very special going on in terms of its game design. I haven't analyzed it super closely myself, because I have not played it a ton. I would be much more into discussing something like StarCraft, StarCraft 2, and why those games work. I'd be much more able to do that. I've not played Persona, and I'm too nervous to, given how long those games go, and how much time investment you need. Final Fantasy is much more palatable for my schedule. It's lengthy, but you can usually beat a Final Fantasy in 15 to 30 hours. And I don't think that's the case with Persona, at least not from what I've heard. I might pick it up one of these summers, though, when I have a lot more time. Then again, even during summers, I'm often crunching on a game project for my studio. So it's hard to get that done even then. Single player versus multiplayer games, it just really depends what the current mood is. Like, there are fantastic elements in both single and multiplayer games, and there are fantastic elements I think you get from games that combine the two. Think about Dark Souls. Think about Demon's Souls, which was probably my favorite in the series. That is a single-player game, I think many would say, but has fantastic and very impactful and just very, very natural-feeling multiplayer elements that can be added onto it. So I think that's a good game that proves that you don't need to necessarily favor one type over the other. They work great together, and they both have their strengths. Oh, Persona soundtracks? Oh, I've listened to those. Those are fantastic. And I do like the dancing game, Persona 5 Dancing All Night. Was it Persona 5 or Persona 4 Dancing All Night? I can't remember. But they have some very funky remixes of some very classic tunes in those games. Despite the fact that my studio makes mobile games, I don't tend to play them a lot. I am very much more of a traditional player. In terms of, I love the more traditional kind of, I don't know what to call it, but kind of the one-time purchase model, where you buy a game, you experience it all the way through like you would a movie or novel, and you just kind of savor it, and that's the end of the story. I do like that kind of model, but I think a free-to-play kind of game-as-a-service model would work. The biggest problem I have with mobile is that I don't like the controls. I tend to not like swipes and virtual joysticks and gestures as much as I love the tactile feel of and responsiveness and reliability of button presses and analog sticks and mouses. So I think that's mainly why. There are a lot of great mobile experiences you can have, but I tend to shy away because of the controls. If I recall, Risk of Rain 2 has a fairly ambient soundtrack. It doesn't have a lot of powerful melodies, but maybe I'm misremembering that. At any rate, I do remember it being very, very appropriate. Okay, I think that's just about it. The questions have gone away from the world of Unity's of technical implementation or game design into my personal life. So let's go ahead and end things there. Thank you, ladies and gentlemen, for tuning in. I will see you, 494 students, I will see you on Wednesday. Don't forget about your Tutorial 1 and Tutorial 2 assignments due Monday, and I cannot wait to play them as you post them into our Project Progress Discord channel. So please don't forget to do that. Thank you, everyone. Take care. Have a safe week.